It's Shannon. It's Shannon. It's Shannon. It's Shannon. It's Shannon. Keeping it real. It's Shannon. It's Shannon. It's Shannon. It's Shannon. It's Shannon. It's Shannon. Keeping it real. It's
Hello, and welcome to
Shannon.
Keeping It Real with Shannon live.
It's Shannon.
Crazy them because you don't know how it's going to turn out.
It's Shannon. It's Shannon.
My kids empowered me to get out.
What's going on with remote learning in the midst of COVID?
Keeping it real.
Working with different elected officials, learning and understanding how to put the community first.
Hello, and welcome to Keeping It Real with Shannon. Hey, Dr. How are you?
Hello, Lottie. How are you?
Well, girl, there's been so much talk about vaccines that were coming out for the COVID-19, and they are here. We need some answers as to whether we should take one of these vaccines. Our special guest tonight is here to answer your questions. Let's introduce him.
Yes, our special guest tonight is Dr. Donald ALCENDOR. He's an associate professor of microbiology and immunology in the Centers for AIDS Health Disparities Research at MEHARRY Medical Center. Dr. ALCENDOR leads the annual HIV/AIDS Awareness Summit for teens and directs the Community Outreach Core for Project SAVE. He's an advisor for the FDA as a Health Disparity Fellowship Mentor, Office of Minority Health. Let's welcome Dr. ALCENDOR.
Good evening. Thank you for having me.
Hello, and welcome.
How are you?
Thank you so much for coming all the way from Nashville, Tennessee to be with us tonight. Thank you so much. Thank you.
Thank you.
Now, you know, we have lost a lot of people from this COVID-19 disease. A lot of people still on the fence. They're still not willing to take the vaccine. They're afraid. They're getting misinformation. They really don't know the full details about the vaccines too. You just start by telling us about the 3 vaccines that's out, and from there we'll go as to why you think that we need to take this vaccine.
So I want to start with a little bit of historical perspective. So it was very clear that by January, this virus was going to be a problem for us here in the United States. It turns out the Chinese had provided the NIH with the sequence of the spike protein from the coronavirus. And it turns out that there has to be something done because people were dying. And the strategy now by the Trump administration was to establish a mission called Project Warp Speed. Now, Project Warp Speed was designed to deliver 300 million doses of a safe and effective vaccine against the coronavirus. And they would deliver these 300 million doses by January 1st, 2021. Now, in some ways, they have delivered on that promise. Again, they had $10 billion to do it. And so there were a number of companies that were involved that got this capital investment from the federal government. And so when money is no object, companies can do a lot of things they would normally do. And so what they did to decrease the time that's required for developing a vaccine, they basically staggered the different phases and ran them together in clinical trials. Normally, a clinical trial involves starting out with a candidate molecule. It turns out they had the candidate molecule on day 1. You see what I'm saying? And so having the candidate molecule on day 1, you start manufacturing and phase 1 at the same time. And then you run phase 2 before phase 1 is complete. And then you run phase 3 before phase 2 is complete. So when you basically overlap the different clinical phases, you are cutting the downtime in terms of making a vaccine down considerably. And so the so-called warp speed was simply taking existing technologies and running them at the most efficient way of doing it. And what you would do now is cut the vaccine time down from about 72 months to about 9 months. Theoretically, to make a vaccine, it takes about 10 to 15 years, a lot of money spent. But when somebody come and tells you money is no object, make it and make it as fast as you can. And that's what they were told to do. They had everything in place in terms of the number of participants. They have basically 3 vaccines that have already made it to the finish line in terms of emergency use authorization. And so that includes the Pfizer, which came first in terms of emergency use, then Moderna, and then Johnson & Johnson. Again, you had as many as 43,000 participants in phase 3 trials. With the Moderna vaccine, you had an efficacy of 94%. With the Pfizer vaccine, you had an efficacy of 95%. And with the Johnson & Johnson vaccine, you had an efficacy in the United States of 72%. Now, these numbers can be confusing, and I want to explain what these numbers mean. So when you think about 94% for Moderna, 95% for Pfizer, and 72% for Johnson & Johnson, these numbers can start to play with your head. In a sense, you would say, well, give me the 95% and give it to me as fast as possible. However, these numbers that in terms of efficacy, meaning a person having no disease at all, in a sense, no severe disease. But when you look at these 3 vaccines and you look for severe disease in terms of hospitalizations and death, all of these vaccines are approaching 100% efficacy. What that means is that don't be misled by these numbers. Again, these are clinical numbers, but when you look at clinical indications for patients, these numbers mean something different, meaning that what you want to do with an ideal vaccine that's worth taking is one that will keep you out of the hospital and out of the morgue. And those 3 vaccines that have gotten early use authorization, they all will do that approaching 100%. So you should not be standing in line waiting for a Moderna vaccine when a Johnson & Johnson vaccine is waiting there for you. I'll give you a little bit of details about these. So think about Moderna at 94%. These clinical trials were done with about 30,000 participants in phase 3. It was done exclusively in the United States, nowhere else. Now let's look at Pfizer. Pfizer was done with about 43,000 participants in phase 3. And that vaccine was tested internationally. The Johnson & Johnson vaccine was tested internationally as well. Now let's say a little bit about what kind of vaccines these are. We start with the Pfizer vaccine. The Pfizer vaccine is considered a recombinant synthetic mRNA vaccine, okay? This is a piece of mRNA that has been generated synthetically. But what it codes for is the glycoprotein spike on the surface of the SARS coronavirus. That glycoprotein spike is the target antigen for these 3 vaccines, all 3 of them. They're all targeted to be able to develop antibodies that will block that virus from getting in your cells to start an infection by binding to this SARS, to this glycoprotein spike. And it does this at a certain efficiency. And if it does this at a high efficiency, then a person would not get infected. Or if they get infected, the infection would be very mild. And
okay, so Doctor, I'm sorry to interrupt you. We have a question that's on the table. They want to know the ingredients in the virus and how you can guarantee safety after.
Can you repeat the question, please?
If the vaccine does not contain the virus, how did they make it? What are the ingredients?
So the idea is that the traditional vaccines have been the whole virus and it's been treated to kill it. Those are the traditional vaccines. A lot of times those traditional vaccines have caused a lot of side effects. And so they came up with another strategy We don't want any component of the virus in certain ways with the mRNA vaccine. We're going to just take the RNA that represents a small piece of the surface protein of the virus, and we're going to give you that wrapped up in a piece of lipid, okay, or fat. And then when we deliver that in your system by injection, the mRNA will be in the cell and it will make the spike protein, and immediately your body will establish an immune response against that spike protein. And the way people will be able to see this, and they will look in your blood and show that your blood is positive for antibodies to the virus. And these antibodies are protective against infection. You do not need the whole virus to establish protection from infection. That's the point I want to make.
Oh.
Okay,
So-
you know what?
Go ahead.
I just wanted to know, since we're talking about the 3 vaccines, we know 2 of them is the mRNA and the other one is the adenovirus. What is the difference in the 2 and the efficacy of them?
So when we think about the mRNA vaccines, the efficacies are very high. We're talking about Pfizer at 95% efficacy at not causing any kind of serious symptoms at all. We're talking about Moderna at 94% efficacy, not causing any serious symptoms at all. And again, we're looking at Johnson & Johnson with a 72% efficacy in the United States. All of these efficacies that I'm giving you now are United States efficacies. Now, some of these vaccines have been tested in other countries like South Africa. And so the Pfizer and Moderna vaccines have been tested other places. Now, the Johnson & Johnson vaccine, this vaccine has been tested in Africa against the South African variant. And it has been shown, and of course, the Pfizer vaccine also has been shown to have some level of protection against the South African variant that we know is here now in the United States and still replicating.
But the Johnson & Johnson vaccine is made with adenovirus.
That's correct. And so to explain that, this is a normal cold virus that doesn't cause you any harm. But what it's very good at, it's very good at getting inside the cell and delivering things. So it is a delivery specialist, okay? And so what they've done is that that same spike protein, they've taken it and they've put it in the adenovirus. And so the adenovirus simply delivers that spike protein as opposed to the spike protein being wrapped up in a lipid ball like the mRNA vaccines. Does that make sense?
Yes, that's me. Yes, thank you.
So Dr. Donna, you know, people, particularly in the minority communities, is always, had, they don't trust the government and what they're putting out. And I think that's why a lot of them don't want to take the tests, but to assure them that they can take this vaccine and that they will be all right. I know you can't say, okay, nothing would never happen to you or whatever, but we don't know. But just to let people know that, okay, it's safer to take it it's better to take it than not to take it.
It is simply better to take it than not to take it. And that's almost regardless of any condition you might have. That includes pregnancy and autoimmune diseases. And it also includes HIV as well. So I'm just saying that this vaccine is simply necessary going forward to protect us and the people we care about. Okay. Now, in terms of side effects, we're talking about side effects that is very similar to the side effects you would get with the common cold, with the influenza vaccine. Okay? Headache, fever, pain at the site of injection, muscle aches. Okay? Now, any kind of severe allergies that you see with these vaccines, usually what people are advised to do is after they get there, if they come to the clinic or a vaccine center to get a vaccine, and they know that they use an EpiPen for allergies, that needs to be known by the vaccine administrators that are there. And of course, if you use an EpiPen, they will be on alert for those individuals. And the idea is that you need to stay around longer than the general 15 minutes that's required. And of course, if you're doing this at a Kroger or a Walgreens, they're going to have epinephrine on hand if you have an allergic response. Now, if you leave too early, get in your car, and you start to have an anaphylactic experience, then that's going to be problematic. Now, the people that have died associated with after getting this injection, not every case has been investigated to the point that proves causation. And when I say causation, I'm talking about the death was directly related to receiving the vaccine. The jury is still out on many of those cases.
Yeah. Well, Dr. Alcendor, we're going to take a quick break, and we're going to be right back for you to continue your talking that you were just doing. We'll be right back.
Okay.
It's Shannon. It's Shannon.
COVID-19 has changed how we express our faith and gather to worship. Now it's time to take the first step that lets us get back to spreading the word without spreading concern. Before we can safely come together, we need the facts. As COVID-19 vaccines become available, you may have questions.
Should I get it?
Is it safe?
Should I wait?
It's smart to question. Now, get the facts at getvaccineanswers.org so you can make an informed decision when vaccines are available to you.
Hi, we are back with our special guest today, Dr. ALCENDOR from Nashville, Tennessee, and he's talking to us about the vaccine. Should I take it? And I'm sure you have been listening to him before of all the information that he has given us so far. So hoping that you were thinking and listen to what he's saying and make a decision as to, whether you want to take it or not. So we had a question on about, what was the question? Where the lipid, I think was the lipid comes from? Where does the lipid come from?
The lipid is simply a company derived fatty acid particle, similar to the fat that you find under the skin of a person. You see what I'm saying? And it's only there to protect the mRNA for a short time once it gets inside the cell. And after that's over, the lipid is destroyed by the cell, and any mRNA that's left around is going to be destroyed by the cell. The mRNA cannot impact your DNA and cause you to have cancer or any other ill effects.
Now, what I want to know is, how long does the vaccine protect us after we take it? Is it
that is a very important question. Shannon, that is a very important question you're asking right now. And again, the jury is still out. I want to remind you that we have been with this virus about a year, about 13, 14 months. And many people haven't got the vaccine. But what we know is that anywhere from 6 to 12 months is the duration time of neutralizing antibodies in the system of a person that has got the disease or have been vaccinated. Now, there is evidence that suggests Tom Hanks' wife became infected with COVID-19. And then she went to the clinic, and she looked at antibodies over time. They followed her antibodies to the virus. After 11 months, she did not have any antibodies to the virus after that time. So that indication of 6 to 12 months is what we know at the moment. Now, the antibody levels, as they wane or fall, could that put us in jeopardy of a reinfection? These are some questions that have to be answered. If that is the case, we might be looking at people getting a booster shot to this virus on a yearly basis, similar to influenza. Does that make sense?
Yeah. Now, would that booster shot contingent upon which initial vaccine you received?
Now, remember, the booster shot might include a vaccine that would take care of the variant as well that is commonly circulating. So the booster shot can serve as a very important tool here. You can get a booster shot that would include both the original strain and the commonly circulating variants at the same time. And you can see the the advantage in having something like that done at a time when you can come in and give a person one booster shot that would be able to take care of an existing variant that is causing infection in the general population.
Okay, so wait a minute, clarification. So I understand like the booster shot and stuff like that, but we don't know yet whether we have to take a booster shot yet.
And again, that's still out right now. Yeah, that's still out right now. Now, again, I want to say that
I don't like needles. Now, I'm letting you know right now, I don't like needles. I'm having a problem now. I took the first dose. I'm waiting to go back for the second dose, and I'm scared for them to stick the needle in. But I know I have to go back, and take it. So absolutely.
And so the idea is that the booster shot can serve a dual purpose here, meaning that it can give you added immunity by basically challenging your immune system again to basically bolster its effectiveness. And the booster shot can have a cocktail of vaccines that can take care of existing variants. And so both Pfizer and Moderna are working on this right now. It turns out that the Johnson & Johnson vaccine is a little different. They would need more time to be able to accommodate a variant in the way they've developed their vaccines. So a synthetic platform for the mRNAs is a very quick way to respond to the viruses that are changing. And that's a very good thing in our toolbox in order to be protected against this virus.
So with the 3 vaccine manufacturers that are out there now, how soon do you think we'll be able to reach that herd immunity?
That just depends on our vaccination rate. So think about it this way. And again, I'm going to go from the most difficult to the most easiest. We got 24% of our population, that is children 17 and younger, that haven't been vaccinated. We have to deal with that. Then you have a level of individuals that say they won't get vaccinated. You have to deal with that. Then you got those people that say, I'm going to think about and wait until I see other people get it and I'll feel more comfortable. You have to deal with those. Then you have to deal with people that want this vaccine right now, and the supply is simply not there.
Okay. We had a question. We had a question on the table. We'll put the question up again. The person was asking, when it comes back up, then we'll answer the question. And it was a question on the table.
I want to talk about something, Shannon, that I think people are not talking about. And that is global inequities in vaccine. I'll give you an example of what I'm talking about. If you're from Nigeria, you say to yourself, where is my vaccines? So we think about this. High resource countries make up 17% of the world's population. However, they have 60% of the world's vaccine supply because they have the money, and they have the money to be able to go out there and buy vaccine contracts. But poor resource countries, I'll give an example. Canada has 100 million citizens, but they're sitting there with 300 million doses of the COVID-19 vaccine. More than they need, you see, even for 2 doses. Nigeria has 220 million citizens, and they don't have access to any vaccine. So if you're saying to yourself, I'm going to vaccinate the United States and I'm going to be just fine, you're on the wrong road.
Absolutely.
You're on the wrong road. We know these viruses can cross borders. We know that. And Shannon, we are a global population.
Yes.
And if you think that vaccinating people in an isolated country is going to protect you, I think you're on the wrong road of understanding the seriousness of this virus.
Yeah, we had the question. I want to go back to the other young lady's question who was asking. We'll answer this question here because I've seen it, but I can't remember what the other one was.
Okay.
About taking your medication before you go take your vaccine. You should still take your medication before you go take the vaccine.
Now, it depends on what medication you have. You know what I'm saying? But generally, you should take your medications. Now, I want to say that if you're having the flu vaccine, you need to wait 5 to 7 days after you've had your flu vaccine to go and get your COVID-19 vaccine. Okay?
We had another
question. There was another question I want to answer the young lady's question. If she
Sure.
could. Yeah, the vaccine is authorized, not approved.
That is correct. And that's a very important indication. Emergency use authorization means that we do not have anything in our arsenal of drugs that have been approved by the FDA that can take care of this. We need something special. And again, we need something special right away. It's an emergency. And so we have to go out there and approve things that don't go in through the normal processes, but they have shown clinically to be very effective. And that's why they get emergency use authorization. But again, I want to say something about emergency use authorization. There's no shortcuts here. There's simply no shortcuts. These clinical trials have to be completed. The data has to be sent to a data safety monitoring board that looks over this data. These are people that are impartial and professional. And they looked at this data and they pass it on after giving it the green light to the FDA advisory board that I have sat on in the past. And I can tell you this FDA advisory board are people that are impartial and they are very smart. And when they give an indication, the FDA usually will follow that indication. After the FDA advisory board gives the green light and then the FDA, the indications then are for the CDC to go ahead and set the standard for disbursement of that vaccine. But true approval will come down the road for these vaccine companies, okay? And full approval is simply different than emergency use authorization.
Wow. So, Dr. Let me ask you clarification on this. Like, okay, say like the United States, you know, is President Biden, is he ordering a vaccine for every state, or do each state order the amount of vaccine that they can afford?
So this is the thing. So a month ago, they had no idea how much vaccine they had on hand, because you had these vaccine companies. One of them were a very small company. The other one was a big company, but they didn't have many doses on hand. And so they had to ramp up their processing, okay? And so now they are starting to get the kind of numbers they need to deliver. But I want to say that what happens is that a municipality is usually given an allocation of vaccines or doses. And those doses are then allocated to different institutions. That means Walgreens will get this, Vanderbilt will get this, and MEHARRY will get that. And so you're given certain number of doses. Now, on a statewide basis, the state has the right to put down how these doses will be allocated. Now, I'll give you an example like West Virginia. West Virginia basically gave the green light to anybody that was 18 and over. You come over here and we're going to give you a vaccine. And they are way ahead in terms of their vaccination rates in that state. You see what I'm saying? And so we have sat back and did age and risk-based assessments for vaccinations. So depending on your age or depending on your risk group. And so these underlying conditions put people at higher risk for severe disease, and they are going to be frontlined. What we did, I think that is very important. And this is why you see, I think, the amount of death has decreased. We have stepped up and we have vaccinated our elderly folks that are in nursing homes. We've done that fairly well, and that has cut down the number of deaths considerably. Now we have to vaccinate the people that are vulnerable in terms of high blood pressure, diabetes, heart disease, COPD, interstitial lung disease, asthma, and so forth. And even when we look at younger people that have come down and maybe died of this disease, they had some of these underlying conditions.
But Dr. Donna ALCENDOR, we're going to wrap up this portion of the show. So we want to thank you for coming on, serving on this part. Absolutely. And hoping that, people that was watching did get some kind of insight onto, whether they should take the vaccine or not, where they think it's suitable for them to take. And, and I hope everybody think about it, but everybody has to make their own decision. No one can make that decision for them. But hopefully, they make the right decision. So we want to thank you for coming on. So we want you to stay around, for our after show, because we have more questions for you. So
absolutely.
I want to thank everybody for watching today.
Okay.
And as always, we'll see you next time.
Absolutely. Thank you for having me.
Today's show is sponsored by Abu's Bakery. If you have a sweet tooth, stop by Abu's Bakery for some delicious cakes and pies.
It's Shannon. 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 Keeping it real. It's Shannon. It's Shannon. It's Shannon. It's Shannon.
Well, thank you for staying around, and
No
thank everybody
problem.
else for staying around. We're going to continue our conversation with Dr. ALCENDOR. So if you have any questions, post them now or comments. He's going to stick around a few minutes to answer some more questions. Now, before we went to break, someone had made the comment about Johnson & Johnson not being trusted because of the baby powder issue from long ago about the baby powder. So
Talcum powder.
I want to say
Talcum
something
powder.
about the Johnson & Johnson vaccine.
Mhm.
Let's take the Johnson & Johnson vaccine. About 85%, 86% effective at keeping you out of the hospital and out of the morgue. This is going to be the cheapest of all of the vaccines. It can be made at a fast rate as well. This Johnson & Johnson vaccine can be kept in the refrigerator you got in your house, okay? And so there's a lot of benefits. When you think about the vaccine that will be used to vaccinate people in developing countries, the Johnson & Johnson vaccine meet the criteria in terms of a vaccine that could be multi-purpose in terms of the advantages it has over some of the other vaccines. And so, again, in places where you need a cold chain, where you need cold temperatures, this Johnson & Johnson vaccine is going to be better than the others in terms of being able to survive in warm temperatures. So I hope in the future that they will have a vaccine that can be lyophilized to a powder. And when it gets to the site of administration or disbursement, you can just put water in it and then go ahead and vaccinate people. Then you'll be able to vaccinate people that are in different environments where you have to go on mountains and so forth. Because what we don't want is to have unvaccinated populations that are infected and continue to spread this infection and lead to the evolution of new variants that can be more dangerous in the future.
So let me ask this question here. I mean, I just want your thoughts on it. Like, okay, so if we still have a lot of people that's not taking the vaccine and they never do take the vaccine, right? So we don't, well, I'm just speaking from my mindset. I don't even know when this would be over with. I mean, will we ever get rid of the COVID virus, or could it be around and we don't know about that it's still around? Even if everybody start feeling good again, walking around like, because we'll never be normal again.
So think about it this way. You need about 75% of the population to be vaccinated. Whether we like it or not or now, about 20% of people, could be as high as 25% of people that have been infected naturally and they have a natural immunity to it. Then you got those people that are coming online every day, 2 million at a time, being vaccinated. It still takes them about 2 weeks to start seeing their immune response to that vaccine. And of course, you still have to stagger that because you need 2 doses. That's 21 days apart for Pfizer and 28 days apart for Moderna. So think about it that way. So what we're saying is that when we start ramping this up to the point where you got 3 million doses, we're thinking by, say, August, you might be at that critical number of 75%. Now, when that happens, you will see something very interesting happen, meaning that the virus will have a hard time trying to find a person it can infect. And when the virus does that, it falls away, meaning that if it can't find a vulnerable person in the population, it can't survive and the virus dies out. And if you get to the point where you've vaccinated enough people, you can eradicate the virus from the population. And we have done that with smallpox. Okay. Now, the idea is that there could be a smoldering infection, but if we have widespread vaccinations on a continual basis, we can keep this virus at bay, just like we keep the influenza virus at bay. And so think about it that way. It is possible, and it's very plausible that we could get to the point where we have a high level of normalcy before the year is out. Remember, there's new indications by the CDC right now. If you've been duly vaccinated, that is, have both of your doses or one Johnson & Johnson dose, you can bring your grandchildren over and you can mingle with them without a mask. You can also bring other dual vaccinated people in your immediate surroundings, not having to social distance and not having to wear masks. However, you're going to see something in the future. If this continues along the same pattern, you're going to see the CDC loosen those restrictions to maybe air travel in the future. You see what I'm saying? So the thing is that it's going to happen, Shannon. It's going to take time, and it's going to take science to guide us through this.
Now, we had a question earlier about kids, little small kids like 6 and 7. How does it affect the small kids when they get COVID, but they don't show no sign of being sick?
So, Shannon, you're asking a very powerful question right now that everybody asks me. And it turns out that this virus, when it affects a child, the virus doesn't go below the neck, so to speak. And what I mean by not going below the neck, for this virus to do its job in terms of making you sick, severely ill, is to get down into your lower airway. That is your lower lung airway. And in a child has a less aggressive immune response. And in an older person has a very aggressive immune response. And usually they have that immune response is accompanied by a very powerful inflammation tornado. So that inflammation tornado that you see in other people, in older people, you don't see that in children. It turns out that children have no underlying conditions usually. You know what I mean? Diabetes, heart disease, and all. They don't have any. Another thing with children is that children have a very powerful means of being able to replicate or reproduce what we call the lung epithelium. Okay? They can regenerate that at a level that's very higher than an older person. So those kinds of issues make children, in a sense, they can be infected. But again, the disease that you will see in them, if they're healthy, will oftentimes be asymptomatic. So you could have quite a few children already infected. And Shannon, to be honest with you, we need to start to monitor how many people have had this virus by doing what we call antigen tests. Yes. Antigen tests would be similar to a pregnancy test, where you would take an applicator, put a biological sample on it, and look for a color change. And if we did that to the point where we can find out, okay, this neighborhood over here is good, but we need to do some work in this neighborhood over here. And so these people, the majority of them are not vaccinated. But over here, even though they're not vaccinated, a lot of them been infected already. And maybe we can pass them by, or for that matter, just give them a boost. And so the idea is that even if you've had COVID and you've recovered, you still need to get the vaccine.
Okay, so I guess that answers the question that was up a minute ago, saying that if you are healthy, if you are considered healthy, should you still get the vaccine?
You know, there's a lot of people that have died that didn't have any underlying comorbidity. Yes. And so all I want to say is that this virus doesn't care who you are, what you do, and how important you are.
I just wanted to ask real quick, if we need a booster, how effective would the booster be for the mRNA vaccine versus the adenovirus vaccine?
Yeah, so you expect the boosters to be quite good. Now, what you want to do to be sure, in science, you want to be sure. You don't want to speculate. And so what you want to do is that you want to do a study that looks at people that got a booster with the with the Johnson & Johnson vaccine versus people that got a booster with the Moderna or Pfizer vaccine. And then you compare the immune response, looking at the amount of neutralizing antibody and the T cell response in those people. And there you've got a scientific answer. Do you see what I'm saying?
Yes, absolutely.
We had a comment that they think the scientists are playing God with our lives. What is your response to that?
I'm saying that science brought this vaccine here, and science is starting to make a difference in this pandemic right now. And it's going to be science that's going to deliver the answer for us going back to normal, meaning that to work on a regular basis, children going to school. And you see, all of these things drive our economy.
Yes.
And what we have to do, and we cannot ignore this, is that we are not sequestered in the world. We are a global economy. And because we have trade and travel and commerce and so forth, any viruses in the developing world are going to find its way here. And we have to be prepared for that. We have gotten a very hard lesson that we don't want to learn more than once, that we have to be prepared.
Well, I'm going to tell you, I just told my girlfriend the other day, I think I'm going to be wearing a mask for the next 2 years.
Well, that's a new norm now, Lottie. So that's okay,
because,
though.
Because it's like you don't know what to expect or what to do. I mean, I listen to everything, that's going on, and I do trust, some of this stuff that they have said and everything, like that. But I guess it's just going to take a long time for me to really just see normalcy again. Because I really just don't think that we're going to ever act like we were before.
So think about it this way. Think about it this way. I'm going to give you some numbers that would suggest it might be time for what you're talking about. So if you look at influenza is going to kill a certain number of people every day. You know what I'm saying? And the idea is that we get down to, say, 150 to 120 people dying every day. That will be in the range of normal general infections. And we start to seeing the people dying, not 3,000, but more in the range of 150 to 200 people dying of this disease. Then I can tell you now, we are approaching that massless day. However, we have to be cognizant that this virus can change, and can change in the worst ways that can cause people to have more acute disease. And so we have to be aware of this. And again, we have to plan for this before it's here.
Again, the next thing. Yeah. Well, Dr. Donna ALCENDOR, we want to thank you again for joining us. We don't want to keep you too long because we know you're still at work working, and you took time away, work to talk to us for a few minutes, and we really, really appreciate the information you have given us tonight. So thank you so much again.
Well,
thank you. And so, as you know, this is Women's History Month, and I will.
Excellent.
I would like to pay tribute to 3 of the women that has really been an influence in my life growing up, because there's always somebody in your life that helps you out when you're growing up. So my first person in my life was she helped raise me as I was growing up when I was young. She was always encouraging and willing to give advice. She helped raise my daughter and other family members. I can remember riding in her red and white Chevy, going to the store to get ice cream and candy. What a treat that was. And my Aunt Esther Pickett from North Carolina, she passed away in 2018. She helped raise me until I was 9. And I came to New York. She had 13 children of her own, but I was number 14. I remember sitting at her table eating biscuits and sopping molasses served with bacon. If you needed a licking, she didn't hesitate to give you one. She was a God-fearing woman, and you better act like a lady at all times. And this is my mom, Johnny Dobson. Passed away in 2006. She was a warm, caring, beloved mother. Made me the woman I am today. She, along with my father, taught me how to be strong and care about other people. She was my best friend and the sister I did not have. She was a mother too. So these are the women that had an influence in my life. My two aunts and my mother. Those were the three women in my life that influenced me, the person that I am.
I feel your pain. I feel your pain because I know a woman just like that. Didn't read or go to school a day in her life, but she sent a boy to Johns Hopkins and to University of California at Davis with no money in his pocket. Just important ideas to make a difference.
Yes, they work hard. You know, they were people who work hard. What they didn't have, they wanted to make sure you had. And, you know, that was my mother and father, you know, and they didn't have a lot of money, anything like that, but they made sure that you was taken care of. And we need those types of women in our life. The young ladies today need women like that in their lives, even if it's not your own mother, aunt, like even if it's an outside person, it's good to have someone in your life.
Absolutely.
You know, and like I say, it's hard, but hey, you know, we move on and do what we have to do. Oh, excuse me. Oh, excuse me.
I understand.
Well, I want to thank everybody for joining us tonight. You know, Vanessa, thank you. And, you know, we want to continue on, be strong, do what we have to do, and let's still stay safe in the COVID because it's not over yet.
Absolutely.
But, you know, make a decision of what you want to do. As I said before, make that decision of whether you think you want to take the vaccine or not. That's your choice. I decided to do it because I was like you, I wasn't going to take it. But then, you know, after talking to the doctor and everything, and, you know, when you start talking about all the problems you have and everything, I said, well, maybe I better run there and get one or something or whatever, you know.
COVID, whatever problem you have, COVID will make it worse.
Yes. Yeah. Well, look, I know what it is to be sick because I know when I had bronchitis one time, you couldn't tell me I had already died.
Yeah.
That's how sick I was with the bronchitis and stuff.
Absolutely.
So I know what it is to be real, real sick. So I can't even imagine the COVID, you know, when people talk about how sick they were with that, you know. But thank you again for, joining us. I really, really appreciate it. And I hope down the road you'll come back again.
Send me the link. Send me the link.
Talk to us again.
Send me the link, okay?
Make sure you send us a copy of your paper.
Absolutely. We'll send you a copy of the paper.
Yes.
Okay. All right.
Take care.
Okay. Thank you. Take care now.
Take care.
See you later.
Have a good night.
Take care, everybody.
Today's show is sponsored by Abu's Bakery. If you have a sweet tooth, stop by Abu's Bakery for some delicious cakes and pies.
It's Shannon. It's Shannon. It's Shannon. It's Shannon. It's Shannon.